Welcome to EDU World Space.
Let's determine whether the series converges or diverges by expressing the nth partial sum. So remember the definition here. The sum, in this case, I should start at 2, not 1. Why is that? Because the sum starts at n equals 2. So this is the sum from A2, A3, all the way up to AN, where AN is given by this expression over here. Now, before we do that, let's just go ahead and rewrite this by factoring the denominator. Let's do n squared minus 1. And then we could factor that even further. N minus 1, n plus 1. Now, what I'll do here is let me just go ahead and I'm going to do a trick. We'll see in a moment why I'm doing this. Let me just multiply by 2 and then make up for that by dividing by 2. Now, I can also go a step further here. So this is 1/2 the sum from n equals 2 to infinity. Now, let me rewrite this 2 as n plus 1 minus n minus 1. The same terms that you see in the denominator. So this n plus 1 and n minus 1 in the numerator didn't come out of anywhere. It came specifically because we see these terms in the denominator, and it just works that way. The denominator, I'll just keep it as is. Now we can go ahead and split this in 2 fractions. We're almost there. We're almost ready to telescope. So that's the first fraction, and I see that n plus 1s will cancel. This is precisely why we wanted those terms in the numerator. We wanted to be able to cancel. Then I have minus. So here I should I'm factoring out the entire sum. And this term as well will also get cancellation. The n minus 1s will cancel. So let's cancel those. Now let's go on to the next page. So we have 1/2 the sum from 2 to infinity. Now on the inside, we have 1 n minus 1 n minus 1 over n, n plus 1. And now we're ready to telescope. So we can write this as a limit as k goes to infinity. Now write the sum as a partial sum. And then let's still write this term in there as well. Now the next step, we're ready to get to work here. We'll go ahead and evaluate this partial sum by writing out some terms. So the limit will not come into play until the very end. So just keep writing that limit. Now we're ready to go ahead and plug in some values. So here you start off by plugging in 2. So plug that in. 1 times 2 minus 1 over 2 times 3. That's the first term. Then plug in n equals 3. Then one more term here. 4 times 5. Then we would keep adding until we get to the last few terms. So here I may not have enough room here. So the very last term, when you plug in k minus 1 times k minus 1 over k plus 1. Before that, you would have plugged in k minus 1. And before that, okay. So now we start canceling as much as we can. we see that we have cancellation here, basically left and right cancellation. And then what will stay, this k and k plus 1 will stay, cancellation again, and it looks like we just have that only the first term and the last term stays. So let's go ahead and write that out on the next page. We have the limit, k goes to infinity, 1/2, and then we had our first term, which was 1/2, and then we had the last term. Now you let k go to infinity, so this is just 1/2 times 1/2, because this term here goes to 0 in the limit, and we get 1/4. So the series converges. We telescoped, and it converged to 1/4, and that's our final answer.